Yeah, good morning, kids. So let us continue with your equilibrium JEE class. First class, I have explained you about the equilibrium constant. So you know the properties of equilibrium constant, how to calculate, and you have, I think, solved also all the questions. So the next topic is, in case now, if you get all the reactants and products in gaseous state, then instead of Kc, we can also represent in terms of Kp now. When to use Kp, first of all, you should understand, you should have only gaseous state. Your product and your reactant should be in the gaseous state only. Product, gaseous, G stands for gaseous state. Now Kp is defined as partial pressure of C raised to the power of its stoichiometric coefficient, P partial pressure of D raised to power of its stoichiometric coefficient, partial pressure of A raised to power is stoichiometric coefficient, and B raised to power stoichiometric coefficient. Now, is it same as Kc? This is what students get out. Kc is what? Concentration. So it will be normally given in terms of moles per liter. So concentration, when I say, is it same as that? No. So prove, I am not going to prove. You studied in school exam and all, they won't ask you. Here just you need to remember this relationship. So the relation between Kp and Kc is Kp is equal to Kc RT delta N. What is delta N now? Number of moles of gaseous product minus number of moles of gaseous reactant. Number of moles of gaseous product minus number of moles of gaseous reactant. So this is the example. So it is not always Kp is equal to Kc. So say for example, N2O4G gives 2NO2G. How many moles of product? 2. How many moles of reactant? 1. So 2 minus 1. So Kp is equal to Kc RT 2 minus N. Here if you see, number of moles of gaseous product, 1 of H2, 1 mole of I2, 2. And here itself 2. So 2 minus 2 0. So RT per 0 is 1. So in this case, Kp is equal to Kc. So be very careful. It is not always they are equal. Similarly, this example you see 4 plus 6, 10. Here 4 plus 5, 9. 10 minus 9. So you get like this Kp and Kc relationship. Now here they will ask you something you have to find. So you have to use the value of R. So be careful with the units now. As I told you, this R is all about units. If SI system is given, pressure is in pascals, volume is in meter cube, you will use 8.314. But normally they will give you in terms of bar and liter. If pressure is in bar, volume is in liter, you will use this value of R. This is the most confusing thing. You always get confused. You have done in solution chapter also. Which value? If one more thing is there, you can also use R is equal to 0.082. If pressure is in atm and volume is in liter, then you will use this. You can use this formula 0.0821. But normally you will give it in bar, and this Kp also normally comes out in bar only. But again, it depends on cases to cases whether it has unit or not. So be careful whether units will be there or not, because depending on what you are going to get, you will get the units. Like in this case, you are not going to get any unit, it will get cancelled out. In this case, you will get units. So normally, whatever the pressure unit, same unit will get for Kp also. Okay, I'll solve some question in the next video. Thank you.